think we're recording. Cool. Um, so should we start from, I guess, like, where would you like to start? Pam, what are your thoughts?
Yeah, yeah. I guess we can start with a bit of like an overview, and then we can go directly to the discussion topics.
Cool, cool. Yeah, so I mean we got the epic. Hopefully the description makes sense. Please let me know if you guys have any feedback on that. And then we can use that to kind of coordinate. Um, and then, of course, we want to basically start the project, start working on the project. So you guys are unblocked, of course, on the embedding side. James, are you helping out with the embeddings work?
Yep, think so.
Okay, awesome. So, yeah, so the sooner we get this started, the better. And I have a few things I want to show you guys as well. But yeah, so I guess we want to go ahead and get started. Probably the three things that we want to go over is API design. I have some things to show there. And then I think maybe we can save divvying the work, how we're gonna divvy up the work for the last part. And then of course we want to know how we're going to start packaging and publishing it. I don't know if Anna um, you have anything there, but does that sound like a good outline for today? Cool. Um, so I don't know if you guys got a chance to look at it. The code is like all over the place. I actually just rewrote a lot of it. Um, I got it working essentially, and then I tried to get it a little bit faster, and now I'm making it pretty. Um, and of course, I would prefer Ruby experts to actually look at the parser itself and kind of see what's going on here. But I wanted a demo at least the parser so you guys can see. I think it's easier to explain what my thoughts are on potentially like what a good API might be that would solve both the knowledge graph and embeddings work. Because I think actually we're going to need very similar data based on what I've read. But we definitely should go over that. So let me share my screen and I can show you guys. Can you guys see my screen? Yes, no, maybe so. Yes. Oh, sorry, I could see it.
Yes.
Cool. So just to show you guys, at least on the knowledge graph side, it's going to look a little bit different because I'm pretty sure y'all's indexer is going to be Golang based. That's is that correct or any changes there?
No, we're using the Golang indexer.
Okay. Is it re-leveraging anything or is it just going to be basically a new indexer from scratch?
It's reusing the Elasticsearch indexer.
Okay.
So
Um,
yeah, it's using the same thing, but we just have like different modes.
okay, okay. Um, One thing we'll probably want to talk about is how you guys are I'll add this to the agenda, maybe under the API design. But one thing I definitely want to touch on is like multi-file analysis, right? But I'll demo kind of what I have for knowledge graph plus parser, and then we can kind of reverse from there and see how we can get it working for both of us. I do think it'll really benefit both of us. But I wanted to walk you guys through the code at a high level of how it works. Um, and then also kind of explain what I'm thinking from a Golang calling into the Rust. I don't know, FFI, if you will. That whole part, I know Anna has been looking into that as well. And then just like basic organizational structure. And then Elwin, it'd be great to, I really want to eventually make this available for um, the language server, so we can just basically remove all the, down the road. That's not immediately, but down the road, remove all the tree sitter stuff and just replace it outright with this parser. So just to walk you guys through it, so it uses a combination of AST grep and tree sitter under the hood. AST grep is essentially a wrapper around tree sitter. So how familiar are you guys with tree sitter? Are you pretty read in with it? Or sorry, not tree, I guess tree sitter too, but tree sitter and AST grep. Are you guys pretty read into it, or AST grep kind of new?
AST grep's new to me.
Okay. Pam, James.
Yeah. Yeah, AST grep's new to me as well.
Okay, so sorry.
It's the same.
Okay. So let me show you guys just a quick demo of AST grep. So if we go to AST grep here, and if I go to the playground, if you guys have heard of semgrep, it's basically a Rust version of semgrep. Not nearly as feature complete because it's newer, but it's now being used by Microsoft and like other companies. And there's a whole company that's based off of this called CodeMod. But if you go to the playground, it's relatively simple once you kind of wrap your brain around it. So if you understand tree sitter, you definitely kind of understand AST grep. And what I mean by that is AST grep is, like I said before, an engine for matching tree sitter nodes. You can think of it as that. So if you've used tree sitter before, Owen, Anna, I think you guys have definitely used that before. Pam, of course. James, I don't know how familiar you are with tree sitter, so please let me know if that's new to you. But what are you gonna
Yep.
say?
Yeah, no, I'm
Feel free
familiar.
to interject too. Like it's totally cool if you cut me off. What were you saying?
I'm familiar with trees. I haven't used it through code much, but yeah, I'm familiar.
Okay. Okay. Yeah, we're basically using it programmatically. So if you're familiar with like the general concept of Lisp, right? And it has a parser for each language, etc. So Um, high level, what AST grep does is allows you to find rules per language or even across languages, and allows you to match and extract information directly from the languages in question AST. So just as a simple example here, you can see this is like a basic Ruby module with a class, etc., right? And we have some comments in here. So if I wanted to match comments in the old tree sitter world, I would have to, write a tree sitter query and then iterate over like run the captures, right, programmatically, which is like there's like a tree sitter API, get captures with the tree sitter query string. And then on top of that, you have to like then extract the information that you want, right? But if I want comments, right, all I have to do is basically go to here, add a simple rule, and be like kind, and I can do comment, and there you go. I've matched all of the comments, and I can extract the comment with like, pattern comment or something like that, right? Oh, whoops, wrong indent. But yeah, so it's like very powerful because this can work across languages, right? Um, where I don't think we should start out that way. I think we should, tailor each language as best as we can, and then figure out how to abstract it from there. But and the reason why I actually went with this is so I've been meeting with Mayor. He's not going to show up. He's not going to be on the meeting tomorrow, but we've been doing research together. But there's an engineer on the static analysis side. He runs the Oxi engine that we've recently acquired. And so he's very familiar with static analysis, and he was like, "You should definitely go with AST grep because it's going to make your life a lot easier." and I didn't know what he meant until I started playing with it, and I was like, this is really powerful. So you can do some really cool rules, like you can see here. You can even look for receiver chains. It just helps you extract what you need a lot easier, right? It's not a silver bullet though. So if we want to do anything fancier, that's what I'm about to show you guys. We're going to need more information than maybe just matches. Maybe in the embeddings teams, you guys might need um, less information, but the knowledge graph needs, for instance, in Ruby here, right? If we need a definition, we need to know, is that definition, so for instance, this singleton method here, right? Let me remove the comment because it's making it really ugly. So this this method here, authenticate, right? We need to know that this authenticate method is a part of this credential checker class and is a part of the authentication checker, right? At least on the knowledge graph side, that would be considered a definition. If we only store the data, authenticate, then you'd get, probably thousands of authenticates, and it's essentially meaningless information, right? I think maybe the embeddings team, you guys might need that. I'm not sure. It depends on like how you guys plan to chunk things, but we can talk about that. But does this make sense high level what AST grep is? I already gave Anna this whole TED talk, so she's probably bored by now, but does it make sense high level? Any questions?
In that example for knowledge graph, you would still use AST grep, right? You would just have multiple AST grep queries to get a single piece of info.
Yes, exactly. And
Gotcha.
so that's what I'm about to show you.
I have a question for knowledge graph. Do you need the entire content of a method or class, or just like the relationship between those methods and classes?
Just a relationship. So we're going to store line numbers, and then if you need the content, we'll probably store the line range, position, and stuff, and also maybe even the byte range. And then that should be sufficient for us. Is that
Yeah.
hopefully?
Okay.
Yeah, if we were storing the whole content, that would be actually kind of an issue. Okay, so just to show you guys that, I just wanted to ground us in that. So then when I go through the library, the new parser library that we're making, hopefully it starts to make a little bit more sense. So I'll go through the code here at a super high level. So the whole point of the library is to use AST grep programmatically, right? And so I wanted to understand what the AST grep API looks like and what we can do, how advanced we can get it, and what it offers us. And it offers us actually way more than I thought initially thought it would. So AST grep essentially is like I said, a wraparound tree sitter. So if you want to actually extract if you want to access the direct AST that tree sitter parsed, you can access that directly and iterate over that tree just like you would if you were importing the tree sitter Rust dependency. And I don't know if you guys know, tree sitter is actually moving to Rust. A lot of their scanners, which actually runs the parsing, is C, but the core Rust, the core part of tree sitter is written in Rust, and they have like first class support. So the API that's why AST grep is able to integrate directly with tree sitter so well, because it's like directly on top of it. And just to show you what I mean by that, if we find, let me find matches, sorry. If we go to matches here and I go to get node, so this is the AST grep core, right? Node. But you can see it uses create node. So these are all the nodes, but I think there should be a method like get tree sitter node. Here we go, node, tree sitter, maybe tree. Oh, here it is, the underlying tree sitter node. So you can see I could even walk through and go straight to the tree sitter code directly from here. So if I go here, This is the tree sitter source code that AST wraps. So developer experience is pretty good. But does that make sense so far as to what I mean by library now is we're using both programmatically. Does that make sense? Or any questions?
Yeah, that
Sorry.
makes
Okay. So just to show you guys, sorry, I'm like dying from allergies. If we go to the left here, I've got this basic library going, and I'll show you the parser actually. So I just have some basic things that's re-exposing AST grep for the most part. Let me restart my NeoVim extension. Sorry. So if you look at this code here, it should hopefully read pretty simple. But one thing we'll want to do when we organize this library is organize the rules effectively. So I have this little helper here. Essentially, what we'll do is we'll define our rules in this rules directory for each language, right? At least for the initial, I think V0, I think would be a good approach. Also, this is not set in stone. Like whatever you guys have feedback on and think we should change, let me know. I'm just showing you what has been working so far when I built this out. But what I'm doing here is I have these rules. They're all defined in YAML, just like AST grep expects. And then for the language itself, for here, I have this Ruby AST. And so this defines like the basic rules that we have. And what I'm doing is I'm statically embedding it into the binary. So when we create the static variable here, it's a global variable, if you would think about it that way. And it's lazy loaded. So only when you call it for the first time will it load it. But during compilation, it'll actually load the YAML string in and load the rules and initialize the rules in memory, right? And so then from programmatically from memory, you can essentially then go to, if you find anywhere where this is used, right? You can see I'm just loading the rules config. So like in the test here, here's a perfect example of like what some sample code would look like. And we'll probably need to think about how Golang is going to do all of this, right? That's a little bit unclear to me. I know we can call Rust directly, right? But what the API looks like might be still needs to be explored, I think. But you can see here we've got like this basic Ruby code. We've got the fixture path that I'm loading up. I actually need to remove this. I think I'm using the wrong code. And so it's definitely some like legacy code, but we can see we're passing in the fixture code, we're parsing it, right? So then we get the AST grep instance, and then we're loading those rules like I told you guys earlier. And then you're able to run the rules, which is just another helper function. And then you're able to extract the matches that way. Does that make sense so far? And what I mean by matches is like pretty much the exact same thing as this. So you can see these matches at the bottom here. I'll even make this bigger for you guys. These matches here. So the matches that we actually want to extract, you can access these matches in memory. And AST grep's API is fully available for us to use for accessing the matches. So if we go to run rules, you can even see I'm iterating over the matches that AST grep found, and I'm able to extract basic information, and we can even return the match node itself, like a reference to it or something.
I have a question. Yeah. So you talked about Go. Are you saying so the rules? I had assumed that like the rules, those CML files, is going to be included in the Rust package. So are you saying that Go itself will that's going to, like when that's being called from Go, does that mean that Go will need to have its own rules, or Can it just be included?
That's up to whatever you guys think is best. So there's two options. We can define the rules in the library, or we can expose an API for you to pass the rules string and return the matches.
I'll
The only
definitely go with the first one. Like, is there a reason why we wouldn't like want to go with that?
um maybe just velocity, like just having to configure the rule in one separate project, and you know, you want to have your rule in the other project. I don't know.
Yeah, I
But
think we'd want to go with the first one just because we don't want the indexer to really know about the tree, like
yeah,
anything about the tree. Like the indexer will just call it
mm,
and then
yeah.
basically just get the chunks.
Yeah, and you're actually kind of ahead as far as what I'm thinking we can do to design the API for what is actually returned. So I wanted to show you guys the second part to this. So this is all extracting the initial information, right? But like I said, it's not fully complete information, like these matches. It only gives you like the match text, right? So for instance, like if you look at this email here, right? This method call where we're calling, where is it? User at email, right? So this is calling this email method here. Um, because it's calling that, this is what's actually, you know, this is what is actually matched. And so if you only take this text, sorry, I don't know what that was. If you only take this text, then this is the only information you have, right? But you guys probably need more information than this, is my guess. Like you want to know what node type of node it is, right? Is it a method or something like that? This is for collecting references. So any type of method calls or function calls, or anytime you're actually calling anything, then I have a separate queries defined for definitions. Does that make sense so far? As to why we need to like programmatically extract more of the information.
Yeah.
And one other thing is I wanted to see how far we could push it, meaning like how, like if the security team wants to come in and write some data tracing flows, is that possible? So what I mean by that is, for instance, if I define here user, right? So user, we're calling the user. I'm assuming this user is like maybe a class or something, right? Or this could even be like a module, another module, user dot whatever, right? I'm not an expert in Ruby, but this is my basic understanding of it. And then it's calling this find by email, which is actually returning an object, right? And then this object, it's actually being passed around, but this object is then being called. So one thing that we want to do though is like when we're extracting a definition, the real definition, at least on the knowledge graph, this might not apply to embeddings, but I figured it's good context. On the knowledge graph, right, the call is here, but the user variable is not. If you only did user.email and you looked up against all the definitions, just like you would in LSP, right? It's not going to give you anything back because that's not the real definition. The real definition is essentially here, right? This is the actual source variable. So I wrote some basic logic to do some data tracing. So essentially, if it finds this, matches this method here, then let's basically create it's called a flow graph, but it creates a flow graph, and we traverse back and essentially find where the assignment is actually made for that variable in question in the given scope, just like a regular compiler would. And we extract the information from there. So then if we wanted the real definition, or sorry, the real origin of the reference, then that's how we would extract it. Does that make sense? Or did I lose you guys? I'm going pretty fast, so.
Yeah.
Um,
Yeah, no, that makes sense. I was thinking, Angelo, if we could I guess do more of an overview discussion so that we can get we can go more into the details later, and then for this meeting I was hoping that we'd come out of it having like an agreement about what the API will be between I guess the Rust parser and then what its output is going to be, and then
Yeah.
which part to really the other question for me is that, so if we're going to introduce a Go module over this one, I think we had some discussions about this repository is just going to have just expose the Rust package. It's just going to be the Rust package, and then it's the module around it that's going to be the responsibility of the indexers. So and then after that, so that's packaging, the API, and then the scaffolding for this project.
Yeah, so I wanted to get to that. Anna, I think probably has some thoughts on there. But before we jump there, I just wanted to close this out to show you guys what I mean. Because this ties into the API design heavily. So just to close it out and show you guys, essentially, TLDR, without going too much in the details, I have defined an API. I'll go to that in the analyzer here. So this API, essentially, we run the matches, we analyze the code, right? But what this does is this here computes the actual data I think we would need, at least on the knowledge graph side, and you might need it on your side. And this is going to be, I think, what we'll probably want to expose as the API. And we might want to even maybe schema this. That might cause some runtime issues, but because it's going to have to translate right from Go to Rust. It's going to be like an object most likely, right, with some properties and whatnot. But if, for instance, you have this, I have definition info and reference info. And to show you guys what this looks like on the file system, so if I go to knowledge graph, because this is where I actually extracted stuff. So this is from the monolith. So if I open this just to preview it for you guys, if the preview will hurry up. Can you see this, or is it too small? It might be too small.
Yeah, we can.
I don't want to fully open it, but so you can see this is the file name, right? Basic stuff. But then I have the fully qualified name for each definition. And then of course we'll want to also extract the line numbers, right? Or the byte range, whatever works for you guys. And we'll want to also probably extract the type, right? So is it a class, a method, a class, a method, module? It'll be definitely dependent on the language too, right? So TypeScript will have types, right? Or an interface. I don't know about too much about Ruby, but we'll want different classifications, right? What I'm thinking is you would pass in the file, you would pass in the language ID, of course, and then you would specify maybe what you want out of it. So I want definitions, and I want these types of definitions, right? Because if you think about it, definitions themselves have multiple subtypes. That's what I'm thinking for an API for V0. It might not scale, but that's what I'm thinking, at least. So you pass in of course the file content, the language ID, and then what you want to extract out of it, and then we add each feature type. So for now, right, I have only definitions and references, and this extracts, again, like I said, the fully qualified name, right? So it extracts the module, the full chunk, if you will, if you're chunking by that. and then of course the line numbers and whatnot. But then it also, what you can do is have the specified match itself, right? So if I go back, sorry, to file system and open this up here. If you just like look at this, right? Tooling, let's look at this. Probably tooling, find files using feature flags, execute, right? You'll probably want to know if each one of these things, what the types of each one of the fully qualified names are. You probably want to know, like, this is a module, this is a module, or sorry, this is a module, maybe this is a class, probably a class, and this is a method, right? So I don't know if we want to extract that data, but it's up to you guys.
Yeah, so question about the language ID. So I was actually thinking that the Rust parser will determine that instead of all of the indexers that will be calling it? Or do we want each of the indexers that's calling it to determine the language and then pass it into the, because it's, if we do it to the on the parser will basically just like, it's the one that will control the
And
language.
then as long as it passes a file path, then I think it'd be okay.
Yeah.
It has to pass something like structured. It can't just pass like the code and then expect us to like determine the code from nothing, right?
Yeah, it will pass in the file path.
Yeah, or file name, whatever one works.
Yeah,
We
it
can do
can
that.
pass in the file path, or I guess alternately it can pass in the content and the language. But my thinking there is that it's
No, file path makes sense because you'll want to configure the different file paths that are supported um, on the parser side, is my guess. So for view, right, you would have a .view file, and then we would want to probably extract, like how we do in the language server today, we'd probably want to extract the script tag, run that through the TypeScript AST parser, and then have a specific parser for the HTML of view and compile it that way. I don't know. But
okay. I'll just put in there so the one parser can determine the language from the file name.
yeah, as long as it has a file name.
Yeah.
So I don't know. I'll definitely write down like what I was thinking here, but I think the more data, the better, right? In case you guys need it, but that's at least what the knowledge graph needs. What we need is like, the fully qualified name, the type of node we extracted, right? So I want to know this is a method. I want to know whether this is like a constant or something else,
I
right?
have another question. So for this query, like you're talking about the definition. So does that cover just the name, like the method definition, or like the method signature, or like the content of the method as well?
It'll give you the by range of the method
Of the like entire content of the method.
yeah.
Yeah.
The closure. So if same coverage, if this is like from lines 50 to 100, then it'll return 50 to 100.
Yeah, yeah. Yeah, okay. Yeah, I have put it in our API that we just need the byte range.
Okay. Yeah, by range might make more sense too. It's probably faster that way to compute things. But yeah, so yeah, we can probably, I don't know if you want to talk offline as far as more of the API things, but that's what I'm thinking for API, like segment it out between definitions, references, like higher level concepts, and then the subtypes in them. Because I know you guys said you said you needed imports and whatnot, right? So maybe imports might make sense as a higher level primitive, if you will. I don't know. What do you guys think? Does that make sense? Owen, does that make sense?
Yeah, it seems good. I had one question about your example of tracing that user variable. Would that be a separate type of way to interface with the parser?
Yeah, so that's the one thing that I also is kind of a kicker because like here I'll show you like what I have. So the reference info, right? I have the fully qualified name, and then I have the origin fully qualified name. And so if this is true, if this is true, then that means it's been assigned somewhere else, right? Otherwise, this is the actual fully qualified name, right? It's not going to be 100%. Like, we're not going to be as good as the compiler, but the goal is to get it good enough for AI to understand it, right? So you'll probably get duplicate matches if you're trying to match, like in the knowledge graph side. But yeah, so that's the one of the kickers. But we can even return like an array of objects for the fully qualified name, right? So you would have like the method itself, but then the fully qualified name is like an array, and it has like the text itself and then the type, right? So I don't know if that makes sense, but
I've put in here on the notes that so the caller will send the kind of segments it needs, so method, class, or anything. So I'm guessing what we'll need is just so the file name, the content, and then how it needs to be chunked.
yes, well, yeah,
Oh.
what I'd like to do is have higher level primitives and then the specific things that it's looking for. And that might be language specific. That's one of the issues, right? So when you call the TypeScript, like a TypeScript thing, right? You're going to want types, you're going to want interfaces, classes. Is there anything else, Owen, that I'm thinking of that's like special about TypeScript that's not in maybe Ruby, for instance? I don't know.
I'll go off my head.
Oh, for imports, for instance, like Ruby has, I think, relative imports, and does it have generic import, right? I think it has like a generic import. So that's why I'm thinking like import would be a higher level primitive. And then you would specify I want relative imports underneath that, right? Does that make sense or no? Pam,
Yeah.
you seem like you're thinking.
No, that makes sense.
Okay, okay. Just let me know. Let me know if I'm way off here. So yeah, so that was that for the higher level primitive. And what's nice, so what I wanted to talk also about multi-file. Are you guys going to pass in multiple files or just
Yeah.
one?
Yeah, multiple files.
Okay. And do you guys have the whole file system loaded up already? Or are the files streamed in to the indexer?
What do you mean? Like it's not going to be streamed, so we're just going to, if I'm understanding the indexer correctly, we're just going to have like per file, we'll just have the entire content of that file, but we're going to be batching that. We're not going to send like the entire file. I mean the entire, like if we have 100 files, we're not going to send
Yeah.
all of that.
Okay, so but are the files gonna exist on the file system is my question.
Wait, which file system are you talking about?
Okay, sorry, in the indexer worker,
Yeah.
right? In the worker, does the worker read files from the files on the file system, or does it call Gitly, for instance, retrieves the file, then you guys are gonna parse it?
Yeah, it calls Gitly.
Okay, so it fetches the content from Gitly, then feeds it back, and then sends that data off somewhere, I'm assuming. Is that the overall?
Wait,
Or
so it gets the file from Gitly, sends it through any of the chunkers, so that can be the size chunker, we still have that, and then the code parser chunker, and then once we have that, once the data, so this is going to be batched, and then each of those content, so we do need that content, but we can determine that from the byte range. That's going to be stored into the into Elasticsearch.
Okay. Okay. That makes sense. So then what we'll want to do is have the API be able to handle multiple files, is my guess.
Yeah. Yes.
Which could be beneficial because then you could even I don't know if you want to do it synchronously or not is the question. That's probably more for you guys to decide, but at least how the knowledge graph works is what I'm doing is I'm spinning up workers. So just to show you, if I run the build, actually let me build it. Release, sorry. Okay. Let me clear it. So just to show you guys on the knowledge graph, this is actually spinning up the whole. It's parsing every single file in the monolith. So what I'm doing is I have worker threads going, and what it does is literally handles each file at a time, but it's in a worker queue. So the API from the Rust might look different, I think, than the Golang. The Golang probably will just accept multi-file, is my guess. Because then on the Rust side, we want to do the file parsing in parallel, right? You guys might want to do the same. I'm just wondering if that would limit your ability to multi-thread, essentially, if that makes sense. So if you pass in 100 files, then the Rust parser, that API will need to create any type of threads for if you wanted to do that. Split up that workload via different threads, if that makes sense.
Wait, so
Otherwise, you're doing each one sequentially.
wait, so what you're saying is that if Rust gets the multi files, it will do all of those files in parallel.
We'd want to probably design the Rust Golang binary to do that if you wanted to do it that way. Otherwise, I would maybe even explore just doing FFI and seeing if Golang handling the threads. We should see essentially. We should measure, does it make more sense to pass in the files as an array? And then the Rust parser is responsible for creating the threads and parsing each one of those files? Or does it make sense that Golang it's the API is one file, or Golang is the API is one file, and the Golang executor is managing the actual parallelization, concurrency, I think it's the same thing, but if that
Yeah.
makes sense.
I see what you mean.
It might be a downside, like if you pass in 100 files and you don't make the Rust have multi-threading, like actually leverage the cores,
Yeah.
then you're literally going to be doing each one iteratively.
So parse files in parallel.
Yeah, if you can write that down, that'd be good.
So this can either, yeah, I see what you mean. I guess like we don't really want the code parser to, like I was imagining the code parser would just be like a dumb parser.
Yeah.
It like just gets either file or single file, but doesn't really
I think single file I would try single file API and seeing how expensive it is to use FFI.
yeah, that's why that's why I initially thought we would want to send multiple files, because Dimitri pointed out how it might be expensive if like Rust is going to, like, if we only send a single file per call, but I guess
He
if we,
was saying it might be expensive to do one call per file, but it might be like negligible. Like I don't know. That's
I,
something
I guess if
whoever's
we
working
parallelize it from the Go side, it should be okay.
should be, I think, maybe. Well, I don't know. It's a big question mark, but
Yeah, okay. Yeah, I guess we can just explore that.
yeah.
Rust code parser or from the Go indexer.
Hmm.
Yeah. Well, I'll put something there that we prefer the Rust code parser to be dumb and not not have to handle threading.
Yeah. I think that would reduce the complexity, but yeah, so that's basically it on the API side. And from what I think. And then the other thing is like how we're going to set up the project, right?
Can we go back to like the method that you showed for the like the function that you showed for that's going to be called?
Like the Rust one, the
Yeah,
like
the
the node.
analyzer, the one that
Okay, I can show you it being used. Let me find it. Where is it? Analysis start. Okay, so here's what I have for on the Rust side. I might even change this to where you need to pass in the matches into the Rust analyzer. I think I might have a bug here where I don't think we should be extracting the matches from there. I think we should be passing in the matches, but that's just on the Rust side. The Golang side would probably API, I think would look something like um uh what is it? What would it be? Like, I don't know. Uh Extract data or something, right? And then you would pass in the file string, which is I forget what Go is like string, right? Or something. Uh and then the file path.
yeah.
Uh,
I guess we can worry about that during packaging. My question was around where is that on the code parser repository? So is that exposed in like a main.rs or somewhere else?
I see what you're saying. Okay, so on here, I have the knowledge graph. This is a separate project. And the GitLab code parser I have here as a source file, source folder, sorry. And then it has lib here. And this exposes the parser, it exposes Ruby specifically. So the Ruby, struct. But I don't think Golang would want this specifically, right? We would want, like I was showing you, like a generic function. And then Ruby has all of the specific things that are specific to Ruby, right? So this has the an analyzer, which gives us the most information, right? That we need. Um, does that make sense?
Yeah. So my question is that yeah, I guess my main question is that ideally from Go we'd really just like the indexer will just know about one method and then that method just it's the only method that's going to be called from the indexer.
I think so. Maybe it might make sense to do per language, so then we can have different types per language. Because have you gone through the FFI yet? The example? I think Anna might have, but um, I don't know if you have. I can show you what I mean, but yes, no, maybe.
No, I haven't. You mean the yeah, I've looked at that one.
Oh, you looked at the where we're calling Rust from Go?
Yeah.
Uh, so what I was saying is like in this one, it might make sense for us to define, for instance, it might look, I think it should look different than this. it might make sense to have, let me show you here, like some definition that it might, I don't know, it might make sense to expose this particular function per language. It might make sense that way. The beauty of the Go FFI thing is you can create headers, right? So we can create a literally like a C header for exactly the data that we're trying to get back to Golang, right? So might just have to play around with it with whatever works best. So it could be one function and takes a language ID, and it could be really dumb, or you could make it a little bit more advanced if you need like particular data per language. So, but I do think the overall package structure should follow something like this in the sense that, so we have this lib here. I don't think we should name it that. I think we should have a crates directory, which is idiomatic for Rust. So actually, let me go over that because I wanted to show you guys. I think there's like an ASCII tree, maybe generator. I just want to like, okay, cool. This is exactly what I want. Let me make this bigger. So what I'm thinking of package structure wise is something very idiomatic to Rust for the Rust code specifically. So we'd have crates, we'd have the core library, right? And then we'd have the Go bindings version. And this would, of course, have the headers .h, right? So everything that you see in the Go parser FFI, so all this stuff here, you see this library and whatnot, and the cbindgen, all the tooling around that could go here. What was it? Headers and basic libraries, so source lib.rs, right? Let me remove this. And core, of course, will have all of the stuff in here. I thought I was adding stuff under there, but I don't know if that makes sense. How do I delete this? I've never used this.
So is this going to be in the Rust code parser, like the code parser repository?
That's what I'm thinking, but Anna might have different thoughts. The way that Kuzu is doing it, so Kuzu's a C++ code base. It's just a graph database. The way that Kuzu does it is they compile their C++ code, and then in the Go bindings repository, they commit the binary directly in here, and then CGO compiles against that. So I don't know, Anna, if you found anything regarding that, but that's what I was initially thinking. It might make more sense that in the Go project, you actually do all of your stuff there, and we just expose an API for like just expose the Rust code, and then you can use the Rust code yourself. That might make more sense for V0. And then we can think about moving that back over to the Rust project.
You
Does that
mean
make sense?
you mean add the Go bindings there?
Yeah, so like in the core parser repository, the Rust code that exposes the bindings, because you need to write Rust code to expose the C bindings, right? So that Rust code could go in the indexer project, and then you just do the whole compilation and everything there. Might make more sense for V0, and then you can just work off the Rust code directly. The other way is actually having the Go package defined in the one parser library itself. But that might be more complex because then we need to actually publish the Golang package, etc. So
See. So in the first solution that you're talking about, we'd still need to publish the Rust. Is it called a crate? Like the Rust crate, and then
Yeah. Mhm.
so the Rust crate, then the Rust crate is going to be used in the indexer. The indexer will have its own like lib.rs just to call
Yep.
Rust crate,
Mhm.
but that's where the go bangs. I see what you mean.
Mhm.
Yeah,
I don't know. Anna, do you have any thoughts on that?
Yeah, I guess I was approaching it from the idea that we would have the bindings in the Rust project, and just like Kuzu does it, um, allow the Go project to get the package that's already been compiled.
Okay. I mean, if it's pretty easy to set up that way, it might make more sense to do it that way, because then the indexer is more dumb in a way, like um, it just is versioned by whatever Go module it's importing, but um, it's up to you guys. Um, I don't know, James, do you have any thoughts? Any questions or anything too? Like, feel free to ask anything.
I personally don't mind which place this which repository this goes in. I guess I don't know which is more complicated. Dimitri
I mean,
might have a better idea once you have a meeting with him. So I'll put in the question here on the notes,
yeah, that'd be great.
and I guess you can ask Dimitri. But honestly, either either way seems to be okay.
Cool. But that's pretty much it. At least on my side. Anything on you guys' side?
Yeah, I guess I'm wondering when we can get started on it. So we'd need like the initial code on the repository for us to get started on it. So will you be committing pushing your code for the Ruby parser, or is that just
I'm trying to make it prettier, so I was thinking we can just start with that. I'm not a Ruby expert though, so I really wish I did TypeScript, but the whole reason why I did Ruby is so I wanted to actually benchmark how fast we can get the monolith parsing to be, and I got it to like 12 seconds. So for 50,000 files, which is like insane actually. I was like, and it initially took I kind of messed up. Initially took 5 minutes to parse. I was like, this is super slow. So I just like, of course, using like the help of AI, like try to optimize as much as possible. And I got it down to like 2 minutes, but I didn't realize I was running the Rust code in debug mode, which means you're running it with all the symbols non-optimized. It's collecting every information. So if you build the production version, it actually optimizes all the bytecode with LLVM. And so it went from like 2 minutes to like 10 seconds. I was like, I feel stupid. This is really
I'd,
funny.
I'd be curious to run that same test, but through FFI and fiddly calls, because I feel like
Yeah.
that's a lot of moving data around, both
Yes.
over gRPC and then through the FFI layer as well.
Yeah. That's a great point. And for knowledge graph, we're going actually probably with the approach that the indexer is going to git clone the entire project, put it on the indexer worker, and we're just going to call it CLI. We're going to keep it super simple now. Like you're just going to say, hey, here's the project path, index it, and give us the output. That's what the Go indexer on the knowledge graph is going to be. At least that's what we thought. But it might be different. I think you guys have a different architecture, right? So you might be more limited in that way. I don't know if you want to load literally every single file from a project into memory, right? The indexer worker on the knowledge graph side at least has the benefit of working with a file system. Like you can just call like like a Linux call. So
Yeah.
Yeah, I almost wonder if we should be like downloading a archive of all the files from GitLab instead of trying to do individual calls. But
Well, I think during like that would solve the, I guess, the initial indexing, but for subsequent indexings, we don't really need to index like get all of the files. We'll just need to get like maybe 5 files that's changed in a get in these like range of commits. Anyway, I think Dimitri and Mandy would be interested too, I guess, like
Yeah,
here.
no, I mean, I'm gonna talk to them tomorrow, so we'll definitely record it so you guys can listen. I wish we were all in like the same time zone, but
Yeah.
um,
I'll just take note here. I think the remaining thing for the API is whether it's going to expose multiple methods per language or one method per, and then just pass in a language ID.
yeah, yeah. I mean, I think my plan is, or at least a thought was, let's try to get some code out there, even if my Ruby code's like not the best, like my actual Ruby parsing and whatnot. And then from there, once you guys have something you can consume, you guys can then immediately start trying to build the Go part, right? I have a POC, but I think it'd be better if you guys took over maybe the Go bindings and see what works best. And like you said, James, like do some actual analysis on what makes more sense as far as like should it take multi-file or not, and where it should live. Um, and then I was going to just structure the project where we have crates so that, you know, in the case that you guys want to do the publishing there, it's pretty easy. We just add a crate, right? Um, that was how I was going to approach it. What do you guys think?
That sounds good.
Cool.
Are
Yeah.
so this one, the MR that you're the Ruby parser MR,
Mhm.
I guess you'll be pushing this to main soon.
Well, I want to get it reviewed, but I want to, yeah. I'll probably need to break it up. It's a lot of code. So,
But that's
um,
the one that we can build off of.
yes, yeah, that's what I'm thinking. At least the library part is, I think, I have a good feel for it. I want to document everything as I go along too. It's going to be more work, but I want to avoid a language server situation where we have like super outdated stuff and it's like a messy code base right at first or anything. I definitely like merged experimental code and whatnot and I had to pay for it later. So I want to do it like nice and clean, like as best as we can up front. Um, so, but yeah. Um, but if you want to review it, that would be amazing. I can tag you guys in the reviews and yes, just start pushing code essentially is the goal. And then of course I need to work with Dimitri on publishing a Rust crate as well. We actually don't even as GitLab support publishing Rust crates to a registry. So we're gonna have to use, I think, tags at first. Yeah, we have npm publishing, we have Golang. I think we have Golang module support on the registry, but we do not have cargo. It's pretty interesting. Yeah, cool. Well, that's it for me. Anything for you guys? Oh, we should think through. You should just keep me in the loop on what you're thinking for how you want to actually chunk things, right? I don't know if you guys have been thinking about it, but I can help in any type of way.
Yeah.
Like chunking strategies, because there's definitely a lot of science and you can make it like really scientific as far as like what you're chunking. Um, I don't know if you guys saw the repo map approach, but I thought that was like really cool. Um, there's and have you seen that where someone created, I think it's called repo map, right? It's like
Yeah.
Can you share that on the agenda, please?
Yeah, it's I think it's called repo map. It's written in Swift. I know that. Aider is another one, but that's not a. What is the name? Do you know the name, Owen?
No, I'm just trying to Google it now.
Can do it
Maybe it's
later.
repo prompt. Oh, it's repo prompt. Here it is. Yeah, I'll link you guys this. What they do something really interesting. They essentially do exactly what we're doing. They create a map of the repository, and it's got like it's like literally like a ASCII tree, but it's all the definitions of each file, and then they feed that into the LLM, and then it's basically got like the equivalent of an API, like API docs. If you go to like some API docs, it's the same thing. But yeah, anyways, we're a little bit over, so appreciate it. Thank you guys.
Yeah, thanks for going over time, especially Angelo and Anna, because it's pretty late where you are.
Yeah, no worries.
Yeah, thanks everybody. See ya.
Cool.
Fizzle.